Hello everyone, this is Anupam. Welcome back. This is the fifth tutorial on the video tutorial series on timers in STM32F4Discovery board. In the previous tutorial, we have built this circuit. We have connected our ultrasonic distance sensor to the discovery board. We have also seen how the distance sensor works. All this we have understood in a graphical way in the previous tutorial. So as of now, we have complete basic background knowledge of how the overall process will work. So now we can start writing the program. You can check out the website. You will find many other STM32F4 Discovery tutorials at the website also. You can even check out the video store at the website. You will find very good video tutorial series there with a very less price. You can even get in touch with me also in case of any query. Just go to contact us page and fill up the form and I will reply. You can check out the forum also. For any tutorial related queries or any technical questions and doubts, you can post comment there and I will reply back there so that other people can also see the comments and what discussion is going on. Please make some donations so that we can create free tutorials as much as possible or keep the price very low of paid tutorials. You are welcome to choose any amount as you like for donation. We will be highly appreciated. You can also support by subscribing my YouTube channel. Thanks. Okay, so let's now start writing the code. Okay, here we have Atomic True Studio. Let's create a new project. Let's name this ultrasonic sensor. Okay, so now our project is created. Let's delete all these comments. Let's delete these unnecessary lines of code also. We do not need them. Okay, so now configure the clock settings. Okay, if you do not understand why I have changed the clock settings, then please check out my previous tutorials on www.logicvoltage.com. Then you will understand everything. Okay, so now our project is properly created. So let's first initialize the GPIO settings for timer 3. Okay, so here we have first enabled the clock for port C, and then we have configured the PC6 pin in alternate function mode for timer 3, and PC6 pin is timer 3 channel 1. If you remember, we have connected PC6 pin from the discovery board to the trig pin on the distance sensor, and we want is PC6 pin generates a 10 microsecond pulse continuously in short intervals. So for that, timer 3 channel 1 needs to be configured. So let's configure the timer 3 first, and then we will configure the timer 3 channel 1 in output compare mode for generating 10 microsecond pulse. Okay, so first configure timer 3. First start the timer 3 clock. Then configure the timer 3. Okay, so here we have configured the timer 3. We have configured the timer 3 to run at 100,000 Hz. That means 100,000 ticks per second. And then we have configured the timer 3 period of 65535 here, and that's the maximum value it can have. We have already learned about this configuration steps in the first and second tutorial also in this tutorial series. Okay, so now next is configure the timer 3 channel 1 in output compare mode so that it will generate 10 microsecond pulse. First declare the structure. in this structure, we have to set values on some parameters. Let's do that. Okay, so now here we have configured the timer 3 channel 1. Here we have set pulse value 1 and OC polarity high. If you remember, we have already learned about this earlier also. At the start of counting, the timer 3 channel 1 will be in high voltage, and here pulse value 1 means when the counting reaches 1, then timer 3 channel 1 will fall and in low voltage, and it will continue to remain in low voltage till the counting reaches 65535. As we have set the period value to 65535, and then when again counting will start from 0, it will again become high. That means timer 3 channel 1 will only become high when counting is being done from 0 to 1, and for rest of the time it will be low. And in 1 second we have 1,000,000 ticks per second. That means the time to count for 0 to 1 will take exactly 10 microseconds. So that means our timer 3 channel 1 will send 10 microsecond pulse continuously forever, and each 10 microsecond pulse will have a gap of 6,553,40 microsecond. If you do some calculation, then you can verify this. Okay, so now our timer 3 channel 1 is configured. Next is start the timer 3 now. Okay, so now our timer 3 is completely configured and initialized, and it's started sending 10 microsecond pulse now to the trigger pin of the distance sensor. Now next is measure the echo pulse that we will receive from the distance sensor. For this, we will use the timer 4. First, we have to configure the PB7 pin in alternate function mode for timer 4. Because if you remember, we have connected the PD7 pin from discovery board to echo pin of the distance sensor. Okay, so now let's first configure the PD7 pin. First, enable the clock for port B. Then configure the PD7 pin. Okay, so now our PD7 pin is initialized properly. It's in alternate function mode for timer 4. Now next is configure the timer 4. Okay, first we have to decide our timer 4 should run in which frequency. We could configure any frequency here, but it's best to choose a bit high frequency here because we want to measure the duration of the echo pulse as much accurate as possible, and high frequency means better accuracy, but don't get too much higher or that will not work. So now here we will put the timer 4 in 2 MHz frequency. So let's configure the timer 4 now. First, start the clock for timer 4. Next is configure the timer 4. Okay, here you can see that I have configured the timer 4 at 2 MHz and period value is 65535. So it will count from 0 to 65535 and then again starts from 0, and it will count total 2 000 ticks in 1 second. Okay, so now our timer 4 configuration is done. Now next is timer 4 channel 1. We have to configure the timer 4 channel 1 in capture rising mode. That means it will keep looking for the rising edge of the pulse that we will get from the distance sensor on the echo pin. If you remember, we have an echo pin on the ultrasonic distance sensor, and that pin is connected to PB7 pin on the Discovery board. And whenever we send any 10 microsecond pulse to the trigger pin on the distance sensor, we will get an echo pulse from the distance sensor on its echo pin, and that echo pulse we will get on PB7 pin. Now one thing to notice here is PB7 pin is timer 4 channel 2 and not channel 1. Now one thing that may come up in your mind is, if we are getting the echo pulse on timer 4 channel 2, then why we are doing anything on timer 4 channel 1? That's because we need 2 channels here. We want to measure the duration of the echo pulse. So timer 4 channel 1 will internally needs to be connected to timer 4 channel 2, and then timer 4 channel 1 will keep looking for the rising edge of the pulse that we will receive on PB7 pin. Now the moment the timer 4 channel 1 gets the rising edge, it will reset the counter value and counting will start from 0. Now then we will configure the timer 4 channel 2 in capture falling mode. That means it will keep looking for falling edge of the pulse in the PB7 pin. Now the moment it gets the falling edge, it will save the value at the counter. That means up to which the counting has been done, and it will trigger an interrupt, and in that interrupt we will get the counter value. That counting value is actually telling the duration of the pulse, and through that counting value we will do some calculation and get the distance. Okay, so first let's configure the timer 4 channel 1 in capture rising mode. First, we have to declare the structure. Here in this structure, we have to set values on some parameters. Let's do that. Okay, so here we have set the timer 4 in capture rising mode. That means it will keep looking for the rising edge of the echo pulse. Now next is configuring the timer 4 channel 2 in capture falling mode. That means keep looking for the falling edge of the echo pulse. Let's do that. Okay, so now our timer 4 channel 2 is in capture falling mode. Now next thing is we have to configure the timer 4 in slave mode. That means on rising edge on the pulse, it will reinitialize the counter and counting will again starts from 0. Let's do that. Okay, then finally we have to start the timer 4. Okay, now we have done configuring the timer 3 and timer 4. Now next is we have to configure the interrupt for timer 4 so that whenever we get an echo pulse and timer 4 channel 2 senses the falling edge, it will generate an interrupt also. For this, first we have to enable the global interrupt for timer 4. Let's do that. First, declare the structure. Then initialize the interrupt for timer 4. If you are not sure how I am configuring the interrupt, then please check out my previous tutorials. I have a complete video tutorial series on interrupts. You can go to www.logicvoltage.com and learn about interrupts properly. Okay, at this point I am assuming you already aware about interrupt concepts. So here we have configured the interrupt of timer 4. Now next is enable timer 4 channel 2 interrupt request. Okay, so now we have the interrupt enable. Now we have configured everything in this program. That final thing that we have to do is write the interrupt service routine for this interrupt. And in this routine we will actually find the distance and show it on the console. Okay, so let's start writing the routine. The name of this routine is timer 4 underscore IRQ handler, as it will handle interrupt request for timer 4. In this function, we will write all our logic of finding the distance. First is here we are clearing the capture compare interrupt bit so that this interrupt is again enabled for handling next interrupt request. Now next is first declare a variable. Then in this we are getting the captured counter value that the timer 4 channel 2 had saved. That means at falling edge of echo pulse interrupt occurs, and at that point of time what was the counting value that we are getting here. So now we have got the counting value here, and this is what we want for finding the duration of the echo pulse and then find distance. Now we have got the width of the echo pulse, or I can say the counting number up to which counting has been done. So now we can calculate the distance. Now how you will convert that counting number into distance in centimeter? Let's do that. Now here you can see that I have printed the distance using the printf function. This I have shown you in the past tutorial also, that how we can print anything on console window. Now here you can see that I have done some calculation on the counting number that we have got from the above statement. I have divided the counting number by 116, and that is the value in centimeter. Actually, you can go through with the data sheet of the distance sensor module. You will find all information there easily on how to convert the duration of the echo pulse to distance in centimeter or any other unit. You can do that easily by yourself. So I am skipping that part here. Okay, so we have got the distance value and it is showing on the console window. Actually, one more thing I have to do. Sometimes we have some connections loose or not proper voltage or any other manufacturing defect. So we might get a wrong value here, and here also I have to do some correction. Let me do that. Here I am subtracting the value by 6. So whatever the value will come, just subtract by 6. That way it showing me correct value. But you might not needed to subtract here, or maybe you need a different value here. So you can check that when we will run this program. And one more thing, let's print the IC2 value also, so you can know side by side what's the counting number we are getting, and then what's the distance. Okay, so now our program is complete. We can now run this program in the discovery board. But before that, we have to configure the things needed for the printf functionality to properly work. If you remember, we have learned about this in the past tutorial. So first add the syscalls.c file. Then write the code in the write function. Then include the header file. Then save it. Now click on Run, then click on Debug. A new window will open. Click on Debugger tab. Enable the serial wire viewer. Write 168 MHz. Click Apply. Click OK. Now we have the debug window opened. Click on Configure Trace button here. Enable port 0. Click OK. Now click on Start Trace here. Okay, so now we are ready, and now we can start the code execution by clicking on this resume button. Let's see. Okay, so now our code started executing, and you can see here we have started getting some values here. Let's see the discovery board also side by side. Okay, so you can see the circuit that is currently running. Now it's showing some distance values here. Let's put something in front of this distance sensor and see how it calculates the distance. Okay, so now you can see the value is changed. We are getting distance 5 cm. Now if I move this hand a little further, okay, so now you can see the values is changed. We are now getting 9 cm, and also you can see side by side it's showing the counted number also. On the basis of this number, we are calculating the width of echo pulse and then distance. Okay, so now you can see how it's calculating the distance by using the ultrasonic sound. Okay, so now our product is complete and it is measuring the distance. That's great, guys. Okay, finally we have created a very cool product of measuring distance using ultrasonic sound. There are plenty of areas where you can use this kind of product. You can build some kind of robotic car or something where you can use this for navigation, and it uses very less power and also much accurate. In this whole tutorial series, we have learned about timers, how to configure timers, what are input compare mode and output compare mode. Then finally we have used timer to create a very cool product using the ultrasonic distance sensor. So that's it. I hope you enjoyed the tutorials. Once again, this is Anupam from www.logicvoltage.com, and thanks for watching. Bye.